Welcome back to the channel. This is Universal Insight on the latest news from around the world. NASA only launched Voyager 1 and Voyager 2. Those viral headlines about Voyager 3 and shocking Uranus discoveries? Pure fiction. But the real story of Uranus, revealed by Voyager 2's 1986 flyby and decades of telescope observations, is even more fascinating. Uranus is a pale blue giant, mysterious and unique, with secrets uncovered by real science, not clickbait. Today we'll separate fact from fiction and dive into the true wonders of Uranus. From its bizarre tilt to its chaotic magnetic field, the reality is stranger than any rumor. Let's explore what we actually know about this enigmatic ice giant. Uranus isn't just tilted, it's practically rolling around the sun, with its axis tipped a wild 98 degrees. For decades at a time, one pole basks in sunlight while the other is plunged into darkness, creating the most extreme seasons in the solar system. This odd tilt likely came from a colossal impact with a massive object early in the solar system's history. That ancient collision didn't just knock Uranus over, it shaped its moons and rings, leaving a permanent mark. The planet's sideways spin means its poles and equator receive sunlight in ways totally alien to us. Strangely, the equator is hotter than the poles, hinting at complex, poorly understood heat flows. Computer models suggest the impact debris formed Uranus's moons and rings. Uranus's tilt isn't just a curiosity, it's a fossil record of cosmic violence. This orientation affects everything from its weather to its magnetic field. The result, a planet defined by chaos, with a climate and character unlike any other. Uranus is a living reminder of our solar system's turbulent past. Saturn's rings are famous, but Uranus has rings too, dark, narrow, and nearly invisible. Voyager 2's 1986 flyby revealed at least 11 thin rings, charcoal black rings, made of ice and dark organic material. These rings reflect almost no light, making them some of the darkest objects in the solar system. Their narrowness is maintained by tiny shepherd moons like Cordelia and Ophelia, which keep the rings sharply defined. Space weathering and radiation have coated the ring particles in carbon-rich compounds, deepening their darkness. Since Voyager, telescopes like Hubble have found even more rings. 13 in total, some tinted blue or red. Uranus's rings are dynamic, evolving, and utterly unlike Saturn's broad, bright bands. They're a subtle, beautiful feature, discovered only because we looked at just the right moment. These rings hint at a violent past and ongoing processes we're only beginning to understand. Uranus's rings are a cosmic mystery hiding in plain sight. Uranus's magnetic field is as strange as the planet itself. Unlike Earth's mostly aligned field, Uranus's is tilted 59 degrees from its axis and offset far from the planet's center. This creates wild variations in magnetic strength across the surface, over tenfold from place to place. As Uranus spins, its lopsided field wobbles and tumbles, creating a magnetosphere that opens and closes to the solar wind daily. The result, a tangled, unpredictable magnetic environment. Scientists think the field is generated not by a metallic core but by a shallow, slushy ocean of water, ammonia, and methane. This super-pressurized, electrically conductive layer acts as a dynamo, but its irregular shape makes the field chaotic. Voyager 2's data revealed a magnetic world unlike any other in the solar system. Uranus's magnetic field is a puzzle, one that challenges everything we thought we knew about planetary dynamos. Its bizarre magnetosphere is a window into the planet's hidden interior. The more we learn, the stranger Uranus becomes. Uranus is the coldest planet in the solar system, with atmospheric temperatures plunging to -224 degrees Celsius. Oddly, it's colder than Neptune, even though it's closer to the sun. Unlike other giants, Uranus barely emits any internal heat. Its energy output is similar to Earth's, which is tiny for a planet its size. One theory, the ancient impact that tipped Uranus also vented its primordial heat into space. Another, strange atmospheric layers trap heat deep inside, preventing it from escaping. Despite the cold, Uranus's atmosphere is surprisingly active, with fast-moving clouds and massive storms. Voyager 2 and later telescopes have spotted bright clouds and continent-sized tempests. Uranus even has auroras, but thanks to its chaotic magnetic field, they appear in unexpected places. All this activity is powered by faint sunlight, proving that even in the deep cold, Uranus is alive with weather and light. The ice giant is a frigid, dynamic world, quiet, but never still. Deep inside Uranus, things get truly bizarre. Scientists believe there's no solid core. Instead, a vast ocean of water, ammonia, and methane exists under crushing pressure and heat. This supersonic electrically conductive ocean likely generates Uranus's off-center magnetic field. Here's the wildest part. Under these extreme conditions, methane may break apart, and carbon atoms could form diamonds. It might literally rain diamonds deep within Uranus, with solid gems sinking toward the core. This diamond rain could help explain the planet's low heat emission and unique interior. Our knowledge comes from models, lab experiments, and Voyager 2's brief visit. To confirm these wonders, we'll need a new mission to probe Uranus's depths. Everything we know about Uranus comes from Voyager 2's flyby and powerful telescopes, but mysteries remain: its magnetic field, its frigid interior, and the possibility of diamond rain. That's why scientists are eager for NASA's proposed Uranus Orbiter and Probe, a flagship mission that could launch in the 2030s. This mission would orbit Uranus for years, mapping it in detail and sending a probe into its atmosphere. It promises to revolutionize our understanding of ice giants, planets common across the galaxy. Until then, stay curious, question the headlines, and keep looking up.